Imagine a world not so long ago where every day was shadowed by the threat of infection. In this world, even a simple scratch or a minor cut could become a death sentence, especially for children and the elderly. Before 1928, this was the harsh reality faced by families everywhere, regardless of wealth or status. Hospitals were crowded with patients suffering from infections that today seem trivial, but back then were often fatal. Doctors did their best, cleaning wounds, applying bandages, and offering comfort. But once infection took hold, hope faded quickly. Then, in a twist of fate, a stray bit of mold floated into a London laboratory, unnoticed at first, but destined to change the course of history. That mold, Penicillium notatum, led to the discovery of penicillin, the world's first true antibiotic, and a medical revolution. For the first time, doctors had a powerful weapon to fight bacteria inside the body, curing infections that once meant certain death. Penicillin's arrival was nothing short of miraculous. It flipped a switch, turning deadly diseases into treatable conditions almost overnight. This wasn't just a scientific breakthrough, it marked a profound shift in our relationship to the natural world, showing us that nature is both a threat and a savior. Thanks to penicillin, organ transplants, chemotherapy, and countless modern medical therapies became possible, saving lives in ways once thought unimaginable. The discovery was quiet, almost accidental, but its impact was immediate and truly global, touching every corner of the world. Penicillin changed how we fight disease, how long we live, and how we imagine our future, giving hope to families everywhere. This is the story of how a humble mold, growing quietly in a forgotten dish, gave millions a second chance at life and a future they never would have had. Alexander Fleming, a Scottish scientist working at St. Mary's Hospital in London, was a man of great curiosity and sharp observation. He was dedicated to studying bacteria and searching for ways to fight infection, but his methods were far from orderly. In fact, Fleming was not known for tidiness. His laboratory was famously cluttered, with petri dishes and glassware scattered across every surface, and notes piled high in no particular order. In the late summer of 1928, Fleming left several petri dishes containing Staphylococcus bacteria on his bench before heading off for a 2-week vacation. He didn't bother to clean up or cover his experiments, simply walking away and leaving the lab as it was. When he returned, he noticed something odd. A blue-green mold had grown on one of the dishes. While mold was a common nuisance in labs, what truly caught his attention was the clear, bacteria-free circles surrounding the mold. Fleming realized that the mold was producing a substance that killed the bacteria nearby. This was no ordinary contamination. It was a clue to something extraordinary. He began to experiment, calling the mysterious substance mold juice. To his amazement, it could destroy a wide range of harmful bacteria, even when diluted many times over. This was a powerful antibacterial agent. Fleming soon identified the mold as Penicillium notatum, and the bacteria-killing substance it produced would become known as penicillin, the world's first true antibiotic. Fleming's scientific curiosity, combined with his years of experience, allowed him to recognize the importance of what others might have dismissed as a simple mistake. Most scientists would have thrown away the contaminated dish without a second thought, but Fleming saw a potential weapon against deadly infections, a discovery that could save countless lives. This was a moment where luck met a prepared and inquisitive mind, leading to a breakthrough that would change medicine forever. Fleming didn't yet realize he had discovered a miracle drug, but he knew he had stumbled upon something truly special and worth investigating further. For nearly a decade, his findings sat on the shelf, largely unnoticed by the scientific community. But the first crucial step toward antibiotics had been taken. Sometimes the biggest breakthroughs in science come from simply paying attention to the unexpected and being open to new possibilities. Fleming's famously messy lab, and perhaps even an open window that let in the mold spores, played a part in changing the course of history. The story of penicillin began with a happy accident, a curious scientist, and a willingness to see opportunity where others saw only a mess. Before penicillin, infection treatments were often as deadly as the diseases. Doctors used toxic chemicals like arsenic and mercury. These cures harmed patients as much as bacteria. Penicillin was different. It targeted bacteria's cell walls, a structure human cells lack. It caused bacteria to burst and die, leaving human tissue unharmed. For the first time, doctors had a safe, targeted weapon against infection. Penicillin could be injected to hunt down bacteria anywhere in the body. It was the magic bullet scientists had dreamed of. path to a world not a man-made chemical. It opened the door to a new era of medicine. To grasp penicillin's impact, picture hospitals before the 1940s, filled with patients dying from infections we now consider minor. A strep throat could lead to heart damage. A cut could mean deadly sepsis. Every surgery and childbirth carried a high risk of fatal infection. Doctors relied on cleanliness and harsh chemicals, but these only helped prevent, not cure, deep infections. For pneumonia or internal infections, all they could offer was rest and hope. Families were large because childhood death from infection was common. Life was fragile, shadowed by the constant threat of invisible killers. Public health measures helped, but individual infections remained a terrifying lottery. The discovery of penicillin lifted a burden of fear that had weighed on humanity for centuries. It gave us security and the expectation of recovery. Penicillin didn't just cure disease, it changed how we live. It allowed us to live longer, healthier lives. The world before penicillin was a world of constant dread. In 1928, Alexander Fleming made a discovery that would eventually change the course of medicine: penicillin. Yet, for nearly a decade, his finding remained little more than a scientific curiosity, tucked away in the corners of his laboratory notes. Fleming struggled to isolate and produce penicillin in any meaningful quantity. The process was painstaking, and the scientific community paid little attention, dismissing his work as an interesting but impractical observation. Everything changed in 1939 when Howard Florey and Ernst Chain at Oxford University decided to revisit Fleming's neglected research. They saw the potential where others had not, and set out to unlock penicillin's promise. Working with limited resources and makeshift equipment, Florey and Chain managed to purify penicillin. The process was slow and inefficient. Gallons of moldy broth yielded only a tiny amount of the precious substance, but it was a breakthrough. Their first real test came in 1941, when a policeman suffering from a severe infection was given penicillin. It was a moment of hope, as the world watched to see if this new drug could succeed where all others had failed. The results were dramatic. His fever dropped, and the infection began to recede. For a brief time, it seemed a miracle had occurred, but the supply of penicillin quickly ran out. Despite their best efforts to recover the drug from the patient's urine and reuse it, there simply wasn't enough. The infection returned, and the policeman died, leaving the team devastated. This heartbreak, however, proved penicillin's extraordinary power and highlighted the urgent need to produce it on a much larger scale. The world had glimpsed a cure, but it was just out of reach. The race was on. Scientists and manufacturers scrambled to find ways to make enough penicillin to save lives, especially as World War II raged and infections claimed countless soldiers. Florey and Chain's relentless work transformed Fleming's overlooked discovery into a practical, life-saving medicine. Their collaboration inspired a global effort. Their efforts proved that penicillin could be a true medical miracle, if only it could be produced in sufficient quantities to meet the desperate need. The world was waiting, desperate for more. Doctors, patients, and families all hoped for a future where infections were no longer a death sentence. The challenge had shifted from discovery to mass production. Scientists and engineers now faced the daunting task of scaling up penicillin for the world. Penicillin's journey from a forgotten lab dish to a global lifesaver had truly begun, setting the stage for a revolution in medicine. The next step was clear: make enough penicillin to change the world and save millions of lives. World War II made penicillin a top priority. In past wars, more soldiers died from infections than wounds. Britain couldn't produce enough, so Florey and Norman Heatley took the mold to the U.S. American labs, and companies launched a massive effort to scale up production. A breakthrough came from a molded antelope, Penicillium chrysogena, produced far more penicillin. Scientists boosted yields further with X-rays and UV light. By 1944, U.S. factories were making enough penicillin for every wounded Allied soldier. Death rates from infection plummeted. Penicillin became a vital weapon of war, saving thousands of lives. The collaboration between nations, scientists, and industry was unprecedented. Penicillin's mass production was a triumph of science and teamwork. The world had its first true wonder drug. Penicillin's wartime success sparked a golden age of antibiotic discovery. Scientists realized microbes in soil and water were locked in chemical warfare, producing natural antibiotics. The hunt for new drugs became a global race. In 1943, Selman Waksman discovered streptomycin, the first cure for tuberculosis. Soon, a wave of new antibiotics followed: chloramphenicol, tetracyclines, and more. Doctors now had an arsenal to fight diseases that once seemed unbeatable. Surgeries and treatments once too risky became routine. Cancer chemotherapy and organ transplants became possible. Antibiotics transformed medicine and extended life expectancy. The world changed at breathtaking speed. Penicillin was the foundation for modern medicine. The impossible became possible. The antibiotic age had arrived. Penicillin didn't just change medicine, it reshaped society. Life expectancy soared from 47 to nearly 77 years in the 20th century. Antibiotics dramatically reduced childhood and adult mortality. Families, economies, and the very structure of society transformed. The fear of losing loved ones to infection faded. Science and medicine became sources of hope and optimism. The pharmaceutical industry exploded, driving research and economic growth. We began to see disease as a solvable problem, not fate. Doctors became healers, not helpless bystanders. But overuse of antibiotics led to resistant bacteria, a new global threat. The miracle of penicillin brought new challenges. Every solution creates new problems. The story of penicillin is both triumph and cautionary tale. Looking back, penicillin stands as one of humanity's greatest achievements. It began with a curious mind and a lucky accident, a moldy petri dish. The journey from Fleming's lab to mass production is a story of ingenuity and collaboration. Penicillin's legacy is in every life saved, every routine surgery, every treatable infection. It lifted a shadow of fear and gave us confidence in science. The story reminds us of the value of basic research and curiosity. Great breakthroughs often come from unexpected places. As we face new challenges like antibiotic resistance, penicillin's story inspires hope and persistence. The next great discovery may be waiting, hidden in plain sight. The legacy of penicillin is not just lives saved, but the enduring lesson to keep searching, keep questioning, and never stop being curious.